last couple days with the last couple problems, and I've been trying to figure out what I've been kind of going wrong with, and I think that I've been kind of treating these problems almost like multiple choice. I've been looking at these descriptions and trying to kind of figure out like what data structure, which algorithm I already know that should be able to apply that is going to fix everything. And I think that's the wrong way to approach these problems. I think I should be really paying more attention to the problem and trying to solve it and treat it like it's new and not just trying to guess what the trick is. I think that's been serving me poorly. So we're going to do things a little bit different tonight. Hopefully we'll have better results. So let's go. All right, so we are performing string shifts. Given a string S containing lowercase English letters and a matrix shift where shift I equals a direction and an amount. Blah, 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 blah. Return the final string after all operations. I want to go back to the blahs. We either get a direction of 0 or 1 for left or right, and amount is a number. So we'll take a string like ABC, and this will say, hey, shift left 1 character. Okay. And then the next one says shift right 2 characters. Okay. So that's pretty cool. So I mean, brute force is really simple. And this sounds like an easy problem, brute force wise anyway. Basically, we just step through our array here and follow the instructions. But the problem is that moving arrays is expensive, basically. If I shift even one amount, then I have to move every item in the array, which is just crazy. And if I'm reading this correctly, then we're really just moving this thing kind of left or right. We're not changing the order of anything. So if we look at the example here, we did 2 shifts. And the first step, we did move that A kind of cyclic around to put it at the end. And then the second one, we moved it to the right too. And you can see, like, if you still read it this way, ABC, it's still essentially in the same order. It just kind of shifted where it is. And so this kind of reminds me of like a circular linked list. I think that's how I want to kind of think about this problem. And in that case, what I'm really doing then is I'm not moving the array, but rather I'm moving where I think about the pointer to the first element, and then I can just follow it all the way through. So if you say shift to the left or shift to the right, I can just move my pointer doing some simple arithmetic and then figure out where the string starts. And then I can have a second function that will go through the array there and do that. So that sounds pretty good to me. So one other thing we talked about last night was the possibility of using a different editor rather than the built-in one. Benefit being that you can do things like write test functions and run those test functions easier. So I like that, and I think we're going to try that tonight and see how it goes. No hints yet, but if it gets to 15 minutes and things aren't looking good, then we might pop those suckers open. I'm going to go ahead and read these last 2 things. Okay, that's not particularly interesting. It basically does what you think it would do. Left shift by 1 takes off the first character and puts it at the end, and same with S. Whoa. And then here at the end, we're going to return the final string. So we are going to return a new string. So if we just move that pointer around, that's going to be... Oh, this is a good example of a constant operation, which means it doesn't matter how long the string is. It doesn't matter how big our input is. This algorithm should run in constant time. And I believe we can do this without allocating extra space. Now, this is a much easier problem than the last couple days, so I'm a little worried that I'm reading it wrong. It's very possible, but I don't think so. All right, so let's pop open code. Code opens to the last project you had open, so hey. That's cool. It's not really anything. So let's just create a new folder for this. Call it desktop sure. Leet code. I can say open with code. All right, get this thing over here and looks good. Okay. All right, perfectamundo. All right, so I'm going to stick with JavaScript, but if we're going to start busting out into other editors, then maybe I'll swap to Kotlin. I don't know. We'll see. So this is called perform string shifts. String shifts.js. I'm going to end up hating that, aren't I? If I end up typing it a bunch of times. All right. Bring up the editor. How's that look? You have to let me know if this is not readable. All right. And so what I'm going to do here is basically run node perform string shifts. All right. That looks good. I'm going to go ahead and grab the instructions here. I'll comment those out. Don't have to keep flopping. And got some noisy dogs here in the background. All right, here we go. So I've got a function that's going to need to string shift, and there's kind of two major pieces that I'm kind of thinking of. One is we'll loop through the shifts and move the pointer. And then we will format the output. All right. So because I'm using a different editor, I'm able to write helper functions, and I can just run those in isolation. I'm not going to bring in any heavy test frameworks or anything. I'm just going to kind of do this old school styley. I can also use a debugger. Yes. So that's really cool. All right. Breath of fresh air. So as we move through shift, we're going to get input. Let's see, do I have an example here? I do not. Well, I have input that looks like this. In fact, let me copy this. And let me go ahead and get the result. And in here, we don't need to need to do a separate function just yet. Let's just go shift.forEach. We'll call this our shift. And here's where we'll have a helper function. And we will let our start index equal 0 to tell us that we start at the beginning of the string. We start printing it out. And that'll be good. Okay. So we need a function. We'll call it move pointer. And we'll do index to keep consistent. We'll pass our string that we're looking at. And we will pass the current shift operation. And we'll go ahead and split it up. That's for you, Dave. We'll unarray this sucker. In fact, we'll even do one better. Direction and amount equals S. Oh, you know, S is a terrible choice here. Call operation. O for operation. Single letter variables. Not Dave approved, my guess. All right. So we've got our string, we've got our direction, and our amount. Now the thing that we're going to change is going to be the start index here. And so we'll just keep changing that. And then here at the end, we will use the start index to print out the rest of our array. So that should be good. So now we need a function called moveIndex, and it takes in string, a direction, and an amount. And I do need to know a start index. So I'm going to have to add that to the argument because that will be my starting basis. So that's pretty cool. All right. So if direction equals 0, I think, for left, okay? All right, the direction equals 0. What we're going to do is we are going to return start index minus amount. Now there is a problem here because it's very easy, especially with our start index being 0, for us to go negative. And so if we go negative, then we need to actually subtract that from the length. And I'm going to write a little note here for test case for going negative. We have another problem too where potentially it's a really big number. Like the length of our string is 4, and I tell you to move left 16 times. So obviously you're going to end up right back where you were, which is just kind of senseless. So we don't need to do that 16 times if we know that it divides easily. So we actually only need to look at the modulus. So I'm going to go ahead and create another variable here called, say, big numbers, actual amount. Set that equal to amount mod s.length. Like that example I mentioned where the string had 4 characters and we want to go around, we want to shift 16 times, and the answer of amount mod string length is going to be 0. And we'll test that. You know, I don't know what 2 mod 4 is. Let's see. Let's Google say 2 mod 2 returns the same thing. So in case our amount is smaller, it's going to end up okay. So that's pretty good. So I think we handled big numbers. We have not handled going negative yet. And this is going to be minus actual amount. Okay, so that looks pretty good to me. Oh, here we'll say we need to return our start index minus amount. So if we just imagine here that this was a 0 minus 2, what we're really saying is string.length minus this amount because it's negative. So what we can do here is basically check to see if we are going to go past that number, the starting index of 0 here. So what that means is if, or we'll go ahead and set a variable, say const difference equals the start index minus the actual amount. So example, we're talking about 0 and negative 2. Then if difference, in this case is negative 2, is less than 0, then what we need to do Then what we need to do is subtract it. So what we're going to do is return s.length minus, well, it's actually a negative number. So we add the difference. Either way, we're going to end up adding the difference. In this case, it's from the length, which is 4, minus 2. So that will get us 2. It's the correct answer. Else, we return this isn't quite right, because start index isn't necessarily 0. So what we need to do here is check to see if the difference in these two numbers, start index and actual amount, is less than our start index. So in this case, we're saying start index is 0 and our actual amount is 2. Hey, how y'all doing tonight? Okay, and then what do we got here? That puts our difference at 2, which is not what I'm looking for here. I think I'm already accounting for that case here. So if our difference, if our actual amount what am I doing here? Something about code and math mixing that just gets kind of squirrely. Let's move these guys out of here. So this accounts for our big numbers. So it'll take a number like 16, get us down to 4. Or rather, down to 0. Say if the direction is 0. Now here's the trick. If the actual amount that we need to move is greater than our start index, then actual amount minus start index. So that will be, in this case, 2 minus 0 will need to be subtracted from s.length. Okay, so in our example here, we said the start index was 0, the actual amount to move was 2. Is 2 greater than 0? Was last time I checked. So now we're going to take our string length of 4 minus the actual amount 2 minus 0, which returns a new starting index of 2. So that's the right answer. Let's try walking through this with a different starting index. So in this case, our starting index is 1. So if you have a string like A, B, C, D, we're saying we're looking at the B first, which makes our effective string B, C, D, A that will return from the algorithm. Then our actual amount is still 2. 2 is still greater than 1. So we're going to take our string length, which is 4 minus, but these don't matter, 4 minus 2, which is 2, minus 1, which is 3, which means we're saying, hey, now your starting index is 3, which means the string now is effectively CDAB. Oh, sorry. This is zero-based array, so it's actually DABC. So that's good. That's it. So that's it for left. Oh, except we didn't do the other side of the else. So if the actual amount, so if our start index was, say, for example, 2, and our actual amount that we need to move was 1, then we just return start index minus actual amount. Done. All right, we're going to test this out here in a minute. Okay. Else. This is going to basically be kind of the reverse here. And hey, if you're just joining, let me know if you need me to repeat the problem. Let you know what's going on, summarize. If the actual amount is greater than the start index, no, sorry. The actual amount that we need to move plus the start index, we'll write the start index first, is greater than s.length, meaning we're going to go over the end. Then what we need to do is return it's going to be s.length. No. So an example here is basically if our start index for ABCD, oops, ABCD, and our starting index is 3, and we want to move 2, say. So actual amount is 2. Then it makes our effective array coming into this thing DABC. So that's cool. And then we're saying we're moving this thing 2 times, which means that we are going to get a start index of 3 plus 2 is 5, which is greater than or equal to our string length of 4. Then the answer we need to come up with is 1. So we get 1 by saying the start index minus, oh no, sorry, the s.length minus, oh my gosh, why can't I think? Isn't it start index? So that will give us 4 minus 3. And basically what we're saying there is we actually need an extra 1 here. So we're saying, how many numbers do you overflow? Okay. So 4 minus 1 minus 3 gets us to 0. And then I want to add the actual amount. So this is going to give me the wrong answer, though. This is going to give me 2. I'm trying to think what I did here. Any help out there? I don't know why I'm just brain dead tonight. You know, there's something about doing these problems every day on top of working that just kind of wears you out a little bit. Brain no worky. I'm here. And I need to go to the right too. So why wouldn't I just say start index plus actual amount, which would give us 5. But then I need to take that and then I need to minus the string length of 4. So I believe that's it. So basically we're saying go ahead and move to the right, and then we're going to subtract the length of the string again. And we're going to test this here in a minute. Okay, so if we aren't greater than the length of that string, then it's really easy. We just return start index plus actual amount. All right, cool. And we can clean this code up a bit. We can shorten that. So that's it. Then we have to format the output. Let's go ahead and test that though. Test this code in isolation here. Once we've got this right, we know we can move on. And let me see, what's our inputs? All right, so that's our signature. So what we're going to do is basically call move index. We're going to give it a string of ABCD. I just realized I'm treating this stuff like I'm passing in an array and then I'm passing in a string here. So we might have something to do there, but we'll see. Direction 1 and starting at 0. So in this case, I'm saying our pointer is at A. And we're moving 1 to the right, so the pointer should be B. So the result we should get back here is basically 1. So I didn't bring in a test framework, and I don't want to. So I'm just going to basically say console log, say does 1 equal. I'll actually drop our function in here. And we'll run this thing. And then look at the syntax error that I've been ignoring all this time. Unexpected token, line 18. Ah, it's true. All right. See what we got here. Oh, total wrong answer. So I know that you can debug, but I don't know how. Let's figure that out. How do you debug a node script? In VS Code. I don't want to do any of this. I don't want to watch a video. I don't want to read all this. I was hoping to just kind of right click something. Oh my gosh. All right. Maybe we won't debug. Why can't I just say run? All right, I'm like 2 seconds from giving up here. There we go, start debugging. All right, got it in 2 seconds. All right, so in here, let's just verify our arguments. We passed ABCD. Yeah, this is so much better than LeetCode, doing it inside LeetCode. 0, which should be left. 1. Oh man, so I think the problem is here, is that I goofed up the results of the test. I think this is actually correct. Well, we'll go ahead and trace it anyway. So I do the mod check just to make sure we didn't exceed the bounds because of some big number. We'll need to test that too. Direction is 0. It's left. Actual amount 1 is greater than 0. Okay, so that all looks good. Step over is F10. So length minus 1 minus 0. So 4 minus 1 minus 0 is 3. And so that's the number we got. So what I did here is I actually got my test wrong, because we're moving to the left from here. So we actually should return a 3. So this was good test. Or rather, bad test. Good code. That's usually not the case. So let's try what I thought I had done, which is moving 1 to the right, which should now return a 1. So let's try running this thing again. I'll get rid of that breakpoint. So hopefully we don't need that. Hey, look at that. All right. So what if we pass a really big number like 16? It doesn't matter which direction we go. So I'll go ahead and do 2 tests, because both should end up being 0. All right. Run this thing again. 0, 0. Oh, it's looking good. And the thing with 16 is, even if we start at a different number, we should end up basically coming back around to that number. Let's try that again. All right, looking good. Try a few more things here. Basically, if we did a 17 and said it was to the right, we should move from a 1 to a 2. Let's see if we got that. Yep. So I feel pretty good about this at this point. We've checked going backwards. We've checked going to the right too far. Let me try one more going to the right. Say you're at index 3 and you move to the right 2. And that should go to position 2. Yeah. So this will test kind of wrapping to the right. Oh, and it says 1, but that's actually correct because arrays are 0 base. So cha-ching. Once again, bad test, correct code. If only that were the case more often. And we've tested both of these now. So good. All right, so we've got a function now that we can clean up and we can run our tests to make sure they still work, which is amazing. So what we can do is just a ternary here, just to reduce the amount of crap we have to look at. I love ternaries. I know not everybody does. For stuff like this, I think it just reads so much better. Oh, you know what else? I've got a plugin called Prettier that if I save, assuming I've got valid JavaScript, which it looks like I don't, it will actually format the code for me, so I just don't have to think about it. It's very opinionated, so it'll bump things wherever it thinks they should go, and I'm fine with that. So what did I goof up here? Unexpected token on. String shift equals function. Okay, that's not very helpful. Loop through the blah. So obviously the error is up here. So I'm just checking my brackets here. I thought I had a plugin called Rainbow. So let's go ahead and get that, because I missed that. Rainbow brackets. And what that'll do is it just color codes your brackets, which is nice. So it's installed, it's just not showing up correctly. Or not like I should, I guess I should say. I've got too many here. I didn't delete. There we go, and see Prettier bumped it to the right spot. Which is awesome. So I do weird stuff like that, and Prettier just jumps it right back. So cool. So if I run these tests again, we should have the same results. There we go. Okay, cool. Well, we could get it down smaller, but I don't really care too much about that. We could make another ternary that's just kind of gross. We don't need an else because there's nothing else that can happen. Alright, so I feel pretty good about that. So we're going to do that a bunch of times. I don't really need to particularly test that. And then the last thing we need to do is just format the output. And the way that's going to look is output out. We'll take a string and a start index, and we'll basically start at that index and move on. And we'll test that as well. And get rid of this garbage. All right, we don't need that anymore. Okay. Oops, wrong thing. And I'll rearrange this to newspaper style. So I love talking about. Basically, so the code reads down. So we start at string shift, and then the next function you see is move index, because that's what we have, and then we'll have format output after that. Some people will argue for alphabetical order. Not me. All right, so here what we're going to do is a for loop. Let I equal to, and here's a trick. We're going to start at start index and then increment. No, we're going to start at 0. I lied. While I is less than s dot length plus plus. All right, and here's what we're going to do is we are going to return a string. That's in the appropriate order. So we'll start an array. Which is going to increase the memory footprint for this algorithm, but I'm okay with that. We'll call this, I don't know, result. Sure. There goes prettier. All right, so what we're going to do is we're going to push s at, and here's the trick. It'll be start index, because we may be starting at a different spot in the string, plus I. But unless start index is 0, we're definitely going to run over. Freaking prettier. So let's do start index plus I mod s dot length, and that'll keep us within the boundaries of that array. And in the end, we're going to return result dot join, and we're going to push this array all back together. And that's it. So now we can take we can test our second function here called format output. We give it a string. And if we pass 0, then it should return us the same string that we pass in, A, B, C, D. Let's see if that works. Okay, cool. Now, if we pass a 1, we should start at B and go B, C, D, A. No problem. And that's what we got. So I think we got all this stuff coded. So it's funny that this is the time that I did code for the editor, and it ended up being totally not needed. So this time we'll start at 3 just because, why not? I'll test every condition but 2. What could go wrong? Okay, that all looks good. Okay, so now we are ready for a real test. And we've got some input here that we got. So now when we run the real algorithm, called string shift. Let's see what we get. And the expected answer is here. We got this from the problem. All right, so we're calling string shift with this string and this matrix. Chances of it working the first time? I don't know, 50%? I'm missing a bracket right there. Is that right? No. Right there. All right, Prettier's gonna format it like that, I guess. That's fine with me. Whatever Prettier wants. Ooh, we got the wrong answer. I'm gonna double check that I copied the right thing, but I think that we're good. Nope, we're not good. So EF Gabside. So what happened here? We're off by 1. All my tests looked good, but good news here is that they gave us some really nice step-by-step instructions here. So let's just see where we went wrong. So this is what we wanted to see. So if I take this and basically shorten this. What's up, Ryan? So this time we actually got a pretty easy one. I think, I mean, I haven't gotten the right answer, so you know. But what we're doing is basically shifting a string around. So we take in a string called S, and then we take a list of instructions where the first item in the array is a direction, either left or right, and the second item in the array is a number, which will be the amount to shift it. So for the example here, you see we've got ABC. This instruction says shift it to the left 1, which results in BC, no, that's down here, BCA, yeah. And then this instruction says move to the right 2, which gives us the result of CAB. So I think this was your suggestion, Ryan, was to do it in code rather than in LeetCode. And so that's what I did, and that let me write some test functions. So I wrote some basic tests, and I was happy with the answers. And then I ran it all together, and I'm off by 1. So I basically just been kind of stepping through the example that they gave me and trying to see where it went wrong. So in this case, they're telling me I should move to the right by 1. So A, B, C, D, E, F, G should go to Gabside. Okay, Prettier's going to format it like that. So let's run it, see if we get that result. So, oops, this is not correct. Let me try that one more time. Yeah, I'm glad for your eyeballs. Okay, so check this out. Oh, no, that's... I keep pasting the wrong thing. I get so nervous when people are watching. All right, so this is funny. So on the first step, I'm already off. It said I should have shifted to the right, but it looks like I've got my left and my right incorrect. That's funny. So they were expecting GAB, and it said I went BCDF, so I wrapped the wrong way. So what I can do here just to test this is swap this function right here and say if it's 1, then we move that direction, otherwise we move this direction. And so what that does do is invalidate all my tests because I misunderstood the rules here. So that's my B. And I'm not going to rewrite those tests. I just delete failed tests. Now we got the right answer, and if we look here, now we got the right answer to the solution. So I think that's it. So what I can do is just take all this right back to LeetCode, try running the code, and this should have the correct answer. Nope. What the heck happened there? What the heck? Oh my gosh. So we got the right answer on the big complicated one and a wrong answer. What the heck? With a little tiny example. So let's try running this in here, and now we can use the debugger. Very exciting. So we'll clean this up here. We don't need to see those anymore. Feel pretty good about those. All right. We'll just do this, and it's we're starting with ABC. All right, and this is our set of directions. Boom. What the heck? Okay, and the answer we expect is cab. Get rid of that stuff. All right, so now when we run this, we'll still see this output, which is fine. And down here, we got the wrong answer. So what happened? We can step through it. When we started with ABC and we said shift to the left 1, we should have gotten, got this up here, an example. When we shift to the left of the 1, we should have gotten BCA here. What did we get? That was correct. Okay. So now when we went from BCA to CAB, should get, oops, the input is BCA, so I'm copying it from the previous step. And the answer is CAB. And this time we're moving 1 and 2. And what went wrong here? What the heck, man? Oh my gosh. What the heck happened? I don't like that. Well, we got a debugger now. So what went wrong? We'll step through. Yeah. We'll comment this guy out for now. We got the right answer. We'll debug it. Oh, I debugged the wrong function. That's not what I wanted to see, so we'll do that again. What I wanted to see was up here. The way the algorithm works is it just keeps changing the start index. So I didn't do any kind of integration-y type test where I ran this thing multiple times. I kind of assumed that it was good to just move it once, so maybe that's where I went wrong. But we'll see. So we start with 0, which is good. And we're moving ABC to the left 1, starting at 0. So the answer I want to see here is moving to the left 1. Let's go ahead and look at the answer. I want to see it actually, I want to see the index go up 1. So the answer I want to see back here is 1. And that's what we got. So now I'm saying, starting from index 1, there's our string, the original string. Our direction is 1 now. We're moving 2. Our start index is 1. Okay. So the answer I want to see coming out of this. Oh, pretty similar actually. I like that. That would have been smart. Geez, that's a really good solution. I didn't think about it that way. I'm doing something a little similar where I'm basically, you start at 0 and I just kind of keep track of whatever the start of the string is. So I could just keep refiguring out where the start is as we keep kind of looping around. But yeah, that's way better. Your solution is way better. And I believe that should work out the same exactly. Wow, that's cool. That would have saved a lot of coding. I think you just listed like the best answer for this. That's really good. And that mine, because of this last stupid step here, mine does have a memory footprint of n, just for putting Humpty back together again for the output. And yours, I don't know. It might have to do the same thing actually. It might have the same runtime and memory footprint now that I think about it, because you still have to, once you know the start index, you still have to assemble the output. All right, so we passed in, we've got a 1. So we're passing it in. So the start index that I want to get out of this is going to be 2. So let's see what we actually got. 0. So there's a bug in my code. So that's good. And this is something we can easily test. So I can say .log, I expected a 2 equal. I'm going to do my move index here. I think we'll try that, adding up all the lefts and rights, and see how that worked out here in a minute after we get this. We'll take the S. All right, and in this case, the S was ABC. The direction was 1. The amount was 2. And the start index in this case was 1. And we said we were happy with that. So the problem is I'm getting 0 here when I expect a 2. Okay, and of course, this doesn't actually return a number, does it? Move index. What I wanted to do was call string. No, I wanted to call move index. This should return a number. What the heck? How did I get the string? Did I not return something correct? What on earth? Oh, this is totally not. What? Am I crazy? How did I get BCA equals ABC? I was trying to see 2 equals something. Let's run that again. Okay, I guess it didn't rerun it. I don't know what happened there. That was weird. All right, 2 equals 0. So that's a problem. So we can trace this though and see what went wrong. Just verify the inputs just to double check. We got ABC, and we're saying, hey, you got to move to the right to a start index of 1. And our string length is 3 here. So let's see what happened. Direction is 1. So 2 is greater than 1. And the actual amount that we need to move is bigger than our start index. That means we need to wrap. Okay? That's fine. So we end up down in this condition, which is, I suppose, what's incorrect. So I said start index minus the actual amount that we need to move. But that's not what I just checked up here. I got this backwards. Should be actual amount minus start index. So this will be now 2 minus 1 instead of 1 minus 2. And JavaScript was fine apparently with me trying to index an array with a negative number. It's just like, negative number, we think you meant 0. Whatever. So I still got the wrong answer though. What the heck? Am I crazy? Did I not save it? Try this one more time. Alright, so we come in here. That's all good. 2 minus 1. Oh, it was 1. Okay. So the result of this whole function should have been 1. So we should have seen 2 equals 1. What on earth? Am I crazy? Alright, one more time because apparently I'm crazy. Is it not reprocessing my change? It's going to step all the way through every line. 2 minus 1 is going to be 0. Oh my god. That is goofy. I found a bug in JavaScript. 2 minus 1 is 0. Step through, step through, step through. Returning 2 minus 1 is 0. Please tell me that you're seeing this. What exactly? I'm just gonna, I don't know what's going on here. I mean, I think it must just not be running. It must not be getting my changes or something. I don't know what's happening. All right. Const result equals, and we'll return the result. And we will log the result. And let's see what we get now. What the heck, man? Result is 0. How on earth did that happen? 2 minus 1. 0. Even this 3 minus 2, oh, minus 1. So this top part does equal 0, but I mean we debugged it, right? Actual amount 2 is greater than 1. So if 2 is greater than 1, oh man, 2 is greater than 1. What the heck? It's returning this line. which also meant that this was correct here. So why when we traced it, did it look like, I guess it wasn't really going to this line is what was happening. It was going to this one. It just looked funky because of how the debugger showed it. Okay. Wow, that was a fun one. I wasted some minutes of my life on that one. Alright, so if we look at it, so here's where we're getting thrown off, is that, well, of course now it's doing it correctly. I don't know what happened there. It was definitely highlighting this line. We were mousing over it and everything. Yeah, so this line right here is wrong. I got the math wrong, which is not a surprise. We took the string length. Yeah, you got me, Ryan. You got me. I do like ternaries, and I don't know why. Maybe I might have to retract that. Oh my gosh. That's the stupidest thing. Okay. So, what are we really trying to say here? Is basically the amount we need to move. I'm getting my left and rights mixed up. Thank you. Thank you. It's on video. If the actual amount that we need to move this direction is greater than our start index, then what we can do is say actual or start index minus actual amount. Is that right? So it's 1 minus 2, so we're at -1 plus 3 is 2, which should get a result of 2. So let's run this thing again. So I'm sorry to report that we did not find a bug in JavaScript in basic arithmetic. Yay. So let's delete this and see how we do on this simple example. Wait, rerun this. Okay, and somehow still I have the wrong answer. No, the output is cab, so that was just me doing something weird there. Okay, so that's good. Now let's see if we pass the big test. EF gap exist. Yep. Okay, so this is it. All right, let's get this, see how we did, and then we're gonna try your solution. So I think that's way better. Okay, ran the code. Oh, okay, I guess that was it. We'll submit it. This is gonna be the first time submitted and got it accepted the first time. Yeah. Okay, cool. Well, let's see how this turned out. Not enough accepted submissions to show the distribution chart. Well, that stinks. All right. So that means I won't be able to compare these answers. That's okay. All right, so now we're going to do your solution, Ryan. I think this is going to be way better. This is going to feel better. It's going to look better. Everything about this is going to be better. And I'm going to delete this stuff. Delete. I'm going to keep format output, actually. We'll just comment that out for now. Or we'll leave it. Screw it. Okay. What we'll do is, and please let me know. Oh, I copied. This is not the right function to keep. This is the right one. All right. So let me know if I say something wrong or if I misunderstood you, but what I think you said was we basically keep a running sum, and I guess we do shift dot for each, or I called it O for operation, terrible one-liner. And the first element is direction. And second one was amount equals O. Okay. And if, oh, we could ternary this and start index, which is maybe not the best name for this. We'll just call it sum. Sum equals direction equals 0, which means we move to the left, which actually has the odd effect of increasing. So I think for now at least we'll do sum plus this amount. All right. Otherwise we'll do sum minus amount. Okay, and at the end of this we'll have some sort of number which is potentially way too big, so we're going to have to kind of normalize it basically. So what does that mean here? Like if I get the answer 16 and my string was ABCD, then I know that this effectively maps to 0. I'm wondering is there a difference between 16 and negative 16? I'm wondering if we could just math.absolute value it. I don't know if that's the case. Say a const start index equals mathematical absolute value of our sum mod the length of the string. Is that it? And then we just format the output. Let's try it. See if I got my left and right correct. It looks like I did not get my left and right correct. So where was that ternary? All right, let's try this again. Oh, I am off somewhere. We'll need to keep the direction if the sum mod the length is not equal to 0. All right, let's take a look at that. We'll put those signs back. Don't need that anymore. So let's go ahead and console.log our sum here and just see what that looks like. So negative 3. So if we look at our input for this problem, which was in order, and we said it was negative 3, what does that mean? What I did was I took the absolute value of 3 and then modded by, you know, whatever number this is, 6 or 7, which just ended up being 3, which is 0, 1, 2, 3. And so I got the wrong answer, off by 1. So I think what you're saying is the negative numbers go past 0. So basically if it's negative, I need to add 1. Am I saying that right? Maybe if it's positive, then I know, then that's easy. Positive is just 0 plus the positive number. If it's negative, I think I have to minus it from the length. Let's see what that looks like. Ternary. If the sum is greater than 0, then it's just going to be sum mod s.length. Okay. If it's less than 0, it's going to be weird. It's going to be s.length minus, and then Here's where I need to do the math dot absolute value of the sum mod the length. Did I do that right? Yay! Okay. That looks good. Let's try the other input, which was like, where was it? ABC. Oh, geez, I keep doing that. ABC. Result should be CAB. And our inputs are 0, 1, and 1, 2. Okay. CAB, CAB. Oh, man. Where's this number coming from? Oh, there it is. So, we got that down to 21 lines compared to 34. And pretty close to 34. I mean, call it 30. So we went from this monstrosity to this. All right. Sorry, I'm excited. This is awesome. So good call, Ryan. I really liked that solution there. I think that's a much better way to do it. It just felt a lot better. And I'm sure we could get the lines of code way down here if we were going to be annoying about it, but I think this is good. We still have the same runtime, I believe. Unfortunately, we couldn't see it. Boom. That's nice, man. That's that was just elegant. So I feel good about that solution. So let me see here. I gotta immortalize. All right, Ryan Monaghan. Let's see what we're gonna say about it. Is a genius. Yeah, man, that's awesome. So thank you. That was really cool. That was a cool trick there. I'm glad you brought that up. I definitely wouldn't have seen that myself. And it was much easier than just the weird stuff I was dealing with. So this just feels good. So that's awesome. I'm very happy with that. Thank you. All right, let's see what the hints say. Okay, shifting is just going to be too slow. Hey, look, hint 2, you may notice that the left shift canceled the right shift. So count both and then just perform it once. So yeah, man, that's slick. All right. Okay, cool. It's locked? What does that mean? What? Is that why you can't see the results? That's a bummer. Premium was like $35 a month. It's crazy. All right, well, I'm going to get out of here. And yeah, only an hour and 15 minutes for this easy one. All right, thank you very much. You guys have a good night.